Hi, good day everyone. This video is about solving logarithmic equations with use of our second method, and that is one-to-one property. Right, so for any logarithmic function f of x that is equals to logarithm of x with the base of b, if logarithm of a number or u with the base of b is equals to another logarithm of a number with the common base or same base as b, then u and b are equal. Right, so let's emphasize this one. Okay, so again, according to this one-to-one property, for example, we have this logarithm of a number. Let's say that number is letter u, okay, with the base of b. Let's say that is equated to another logarithm of another number. Let's say that is letter v, okay, logarithm of v with the same base. Okay, so for one-to-one property, if you encounter some logarithms with common base or same base, right, so if this value of b is equal to another set of value b, okay, automatically the value of u and v are equal. Okay, so just equate those given values. So let's try to solve some problems involving or using this one-to-one property. Right, so let's try to answer item number 1. So for problem number 1, okay, let's say we have this logarithm. Okay, let's say logarithm of 2x with the base of 4. Let's say that is equals to another logarithm. Say logarithm of 10 with the base of 4. Right, so to answer this, since we want to apply this one-to-one property, as you observe, we have this common set of base. We have this 4 and another 4. So our next step is to simply equate the value of u and v. So for our first example, we have this u and we have this v. Okay, so just equate those given values. So it will give us 2x, and that is equals to v, that is the value of 10. And solve for the value of x. Okay, so since we're solving for the values of x, just divide this expression by 2. Okay, so cancel out 2. Therefore, x is simply equals to 10 divided by 2, and that is equals to 5. Okay, and that is our final answer. Right, so that's the concept actually of this one-to-one property. Okay, so let's try to answer another set of problem. So for example number 2, okay, so for example, let's say we have this logarithm of an expression. Let's say we have 4x minus 3, and that is equals to logarithm of another expression. Let's say that is 2x plus 5. Okay, so for this given problem, since we are dealing with common logarithm, okay, so automatically the values of our base, we have 10. Okay, we have this invisible 10 for this expression and another invisible 10 for this expression. So automatically, if you want to use one-to-one property, just equate the value of u, okay, so which is the value of 4x minus 3, that is our u, and the value of v, which is 2x plus 5. So let's equate those values and solve for the value of x. So it will give us 4x minus 3 as u. That is equals to 2x plus 5 as the value of b. Okay, so let's solve for the values of x. Right, so let's combine like terms. Again, it's up to you if you want to transpose the values of 2x and transpose the value of negative 3. So it's up to you. Again, our goal for this part is to simply isolate the value of x. Right, so I think let's apply APE for this one. Since I want to remove negative 3, let's add 3 both sides. Okay, and since I want to remove 2x for this part, let's subtract 2x both sides. Okay, and simplify. Right, so let's simplify this one. Therefore, to give us, again, that is 4x minus 2x. So cancel out 3, and that is equals to 5 plus 3, cancel out 2x. Okay, so let's simplify this one. So it will give us 4x minus 2x, that is equals to 4 minus 2, that is 2x, and that is equals to 5. Okay, 5 plus 3 equals 8. Okay, so let's solve for the values of x. Okay, so let's divide this expression by 2, both sides, cancel out 2. Therefore, x is equals to 8 divided by 2, or simply 4. And that's it. So that is our final answer. Right? So that is actually the concept of one-to-one property. So next, let's try to solve another problem. So example number 3. Okay, so for example number 3, let's say we have this logarithm of 3x plus 1. 3x plus 1 with the base e. Okay, and that is equals to another logarithm of 10 with the base e. Again, this one-to-one property is actually applicable. Okay, it is only applicable for expressions or functions with a common base. So for this given problem, since we have this logarithm of 3x plus 1 with the base e and logarithm of 10 with the base e, automatically we have this common set of base. So just apply this one-to-one property. Right, so let's equate the values of u and v. Okay, we have this u and we have 10 as the value of v. Okay, so let's equate. That means it will give us 3x plus 1 and that is equals to 10. And solve for the value of x. Okay, so I want to remove this 1, so let's subtract 1 both sides. Okay, so it will give us 3x, cancel out 1, and that is equals to 10 minus 1, that is equals to 9. Okay, since we have this 3x is equals to 9, let's divide both sides by 9, or 3 by the way, so that is 3, cancel out 3, x is equals to 9 divided by 3, or simply 3. And that's it. So that is our final answer for this given problem. Okay, next, another problem. So for example number 4, say we have this logarithm of, say we have 12x minus 7, and that is equals to another logarithm of 3x, say plus 11. Again, I encourage you to pause this video and let's try to solve this problem on your own. Okay, alright, so let's answer this. Again, since we have this common logarithm, so we have this invisible base as 10, so just equate, okay, the values of u and v. So the value of u, we have 12x minus 7, and that is equals to the value of v, that is 3x plus 11. Right, so let's combine both like terms. So I want to remove this 7, so plus 7 both sides, or simply transpose the value of 7 if you want. Okay, and I want to remove the value of 3x for this part, so I will subtract 3x both sides, minus 3x both sides. Okay, so let's simplify. So it will give us 12x minus 3x, okay, and cancel out this negative 7, and that is equals to 11 plus 7, cancel out 3x. Okay, so let's simplify this set of expressions. 12x minus 3x, that is equals to 9x, that is equals to 11 plus 7, that is equal to 18. Okay, so let's solve for the values of x. Again, that is 9x equals to 18, divide both sides by 9, cancel out 9, and the value of x is simply equals to positive 2. So try to double check your answer. Okay, so that is equals to 2. Okay, next. So let's try to answer our example number 5. Okay, so how about example number 5? So for our fifth example, let's say we have this problem. Let's say we have this logarithm of 5x, and that is equals to logarithm of 2x plus 9. 2x plus 9. Okay, so same procedure. So since we have this common logarithm, we have this common set of base, we have this invisible 10, just equate the values of u and v. So for the value of u, we have 5x. For v, we have 2x plus 9. Okay, and simply combine like terms. So I want to subtract 2x both sides to isolate the values of x. Okay, so it will give us 5x minus 2x, that is equals to 9, because I cancel out this 2x. Okay, so let's simplify. 5x minus 2x, that is equals to 3x, that is equals to 9, and 3x equals to 9, divide both sides by 3, obviously the value of x is simply 9 divided by 3, or simply 3. So that is the answer. Okay, so that is for example number 5. So for example number 6, let's try to solve some problems or expressions with a degree of 2. Okay, so for example, let's say we have this natural logarithm, or ln. Okay, say we have this ln of x squared plus 12, that is equals to ln of negative 9x minus 2. Right, so let's try to answer this given problem. Since we have this ln, or natural logarithm, so natural logarithm again are logarithms with a base of e. Okay, so automatically we have this common base. So let's just equate the values of u and v. So for the value of u, we have this one, okay, that is u. And for the value of v, we have this expression, right? So let's equate those values. So it will give us x squared plus 12 is equals to negative 9x minus 2. Okay, so that is our expression. Since we want to combine like terms, so just combine like terms, right? So I want to move this value of 9x, and again, since we have the second degree, I think I need to move the value of negative 2 also. Okay, so let's add 9x and add 2 both sides. So plus 9x and 2 both sides. So it looks like we simply transpose the values of 9x and 2. Okay, so my task for this part is to write this expression into its standard form. So therefore it will give us x squared, okay, plus 9x plus the remaining value, which is 12, okay, plus the move value, that is 2, and that is equals to 0. So just cancel out this set of values. Okay, so let's combine like terms. I think we have this like terms. We have this 12 and the value of 2. Okay, we have 12 and 2. So let's simplify. So it will give us x squared plus 9x plus 14, and that is equal to 0. Right, so since we have this given expressions, our next task is to solve for the values of x. Since we have this quadratic equation, again, we have 4 methods. It's up to you. So it's either factoring, completing the square, extracting the square root, or with use of quadratic formula. I think for this given problem, let's try to use factoring. Okay, so let's try to factor this given problem. Since we have this x squared plus 9x plus 14, right, so I think the factor of this given value, we have x and another set of x. Again, for factoring, we need to think or provide two sets of values, wherein the product is our last term and the sum is our midterm. Right, so let's factor out 14. I think the possible values for 14 is 7 times 2. Okay, so if we have 7 times 2, that is 14, and 7 plus 2, that is equals to positive 9. So good. So we have this correct set of factor. That means it will give us 7 or x plus 7 times x plus 2. Let's equate this one 0. Okay, so let's solve for the values of x. So just construct the table since we have this factor and equate each factor to 0. So x plus 7 is equal to 0 and x plus 2 is equal to 0. So that means the value of x of 1 is equals to negative 7, and the value of x of 2 is negative 2. And that is our final answer. We have the solutions, okay, as negative 7 and, or by the way, negative 2. Okay, that is our example number 7. Next. So for example number 8. Okay, so by the way, so I will count again. So we have 6, by the way, that is example number 7. So next is example number 7. Right, so let's try to solve this one. Again, logarithm of 16 plus 2x, and that is equals to the logarithm of x squared. Okay, so another second degree function or expression, minus 4x. Right, so let's try to solve this one. Again, same procedure, common logarithm, common base, apply one-to-one property. Just equate the value of u and v. So the value of u, we have 16 plus 2x the value of b, we have x squared minus 4x. Our next step is to combine like terms, or simply write this given expression into its standard form, okay? So I think I need to move the value of 2x and the value of 16. Okay, so let's subtract 2x both sides, and let's subtract 16 both sides. Okay, so it will give us x squared minus 2x minus 4x minus 16. So just cancel out this set of values. Automatically, this expression is equated to 0. Okay, so let's simplify this one. Let's combine like terms. I think we have this like term as 2x and 4x. Okay, so it will give us 0 is equals to x squared. Negative 2x minus 4x is negative 6x minus 16. Okay, so let's solve for the roots, or let's extract the roots of this given expression. Since we have this standard form of a quadratic equation, so let's try to use factoring. Okay, let's factor this one. We have x and another x, and that is equal to 0. Right, so again, same procedure. We need to think of a value wherein the product is negative 16 and the sum is negative 6. Okay, so I think let's try to use negative 8 and positive 2. So let's try to test. Negative 8 times positive 2, the answer is negative 16. Okay, next, negative 8 plus positive 2, the answer is negative 6. That means the factor for this given expression, okay, is negative 8 and positive 2. So let's add 8 and, by the way, subtract 8, subtract 8 and add 2. So we have this given binomials. So let's construct the table and solve for the roots. Right, so again, let's equate each factor or binomial to 0. So x minus 8 is equal to 0, and x plus 2, and that is equals to another 0. So obviously the value of x of 1 is positive 8, and the value of x of 2 is negative 2. And that is our final answer. Okay, so that's it. So next, actually for our examples number 1 to 7, we actually disregard or cancel out the values of our logarithm together with the base. This time, let's try to answer our example number 8. Okay, so for example number 8, again, let's say we have this 2 raised to x, and that is equals to 3. Right, so it is just a simple exponential expression or equation wherein we need to think of a value of x that will satisfy this given expression or equation. Since it looks like it is impossible to provide the whole number, okay, as the exponent of 2, and the answer is 3, right? So I think if the expression is 2 raised to x and that is equals to 4, that is possible to solve. So it will give us 2 raised to 2, right? So 2 raised to 2 is equals to 4. But for this given problem, we have this answer as 3, right? So we need to use the concept of logarithm to solve this one, right? So our first step is to add logarithms for each of the term, okay? So with use of one-to-one property, we need to add, I think, logarithm of common base, okay, for each of the term. Since we have this 2x, 2 raised to x, by the way, and 3, so this first expression will serve as the value of u, and this 3 will serve as the value of v. Okay, so let's add logarithm for each of those terms. So to give us logarithm of a base, okay, I'm not sure what is our base, so let's use common logarithm or use the base of 10. So we have this logarithm of 2 raised to x, and that is equals to the logarithm of v, or the value of 3. Right, so let's apply common logarithm since we have this common set of values. Okay, for this part, we need to use or apply the power property. Okay, so since we have this exponent, so that is actually equals to x times logarithm of 2. Right, again, this entire expression is actually equals to this one. Why? That is according to the power property. So what do you mean by power property? So for the power property, that is equals to the logarithm of a number with the base of b and raised to another number. Okay, since the value of our logarithm is raised to an exponent, so actually we are allowed to move this value in front of our logarithm. Okay, so this expression is equals to n times logarithm of u with the base of b. Okay, so that is um, the power property. Okay, so by simply applying the power property to our given expression, since we have this logarithm of 2 raised to x, right? So the logarithm of a number, we have this exponent, so let's move this value of x in front of our logarithm. Okay, so let's equate this one, so that is equals to logarithm of 3. Since we're looking for the value of x for this given problem, so same procedure, we need to um, isolate the value of x. I think we need to remove this logarithm of 2 and just divide this set of expression to logarithm of 2. Right, so let's cancel out this one. Therefore, the value of x, okay, so for this given problem, x is equals to logarithm of 3 all over logarithm of 2. And that is our final answer. Right, so it's up to you if you want to use calculator. Actually, we have this value for this logarithm, so let's divide this set of values. So with use of calculator, I think the value of x is approximately, okay, so that is not equal, so we are just approximating the value, approximately equals to approximately 1 point, I think 1.58 and 4. Right, so again, if you want to double check your answer, okay, let's use calculator for this one. Right, so that's it. So that is actually the procedure.